Hi, this is Mrs. Robel. So this is the last video that I'm going to make for the week. And here I'm actually going to talk about two different topics because you're going to be doing a home lab. Yes, you're going to be doing a home lab, and I think you'll enjoy it. So we are going to focus in today about Q and Kc. So Kc is the equilibrium constant, and Q is the reaction quotient. So I don't know if you remember from the notes that you did the other day, reaction quotient, we don't know if it's at equilibrium, and we're trying to figure out, is it at equilibrium? So what we do is a little bit of a litmus test to see how close it is to equilibrium. So this first problem here, they say that the Kc is 5.10, so that's pretty big. And remember, it's products over reactants, so the products are going to be higher in concentration than the reactants. And I said that when we're talking about reaction or equilibrium constants, we only want to look at gases, or we want to look at aqueous solutions. So if it has solid or liquid in the description of the substance, you do not want to put it as an equilibrium constant. So I'm going to write the Kc for this reaction, and it's H2 times CO2 concentration in molarity over CO times water. And notice they're all gases. So when they give you concentration, and notice that it could be, this is kind of a funky concentration here. This is moles per decimeters, okay? You can use that kind of concentration. It is fine. Now, the way I would set it up is I would say Q is the same thing as we listed for Kc. And then I would plug in the different concentrations. So for H2 it's 0.42, for CO2 it's 0.37, for CO it's 0.15, and for H2O it's 0.25. Okay, and when you do the math, you come up with 4.1. So notice that Q is less than Kc, okay? So since Q is less than Kc, it can shift more to the left, to products. So it'll shift to the right because it needs more products. Okay, so I'm going to have you do this second reaction quotient. Okay, now we're going to move on to Le Chatelier. So you're going to do a lab where you're looking at Le Chatelier. And I don't know if you remember from the notes that I talked about Le Chatelier, it's a stressor. And the stressor usually causes the direction to go in the opposite path of that stress. Okay, and I think I talked about the fact that, we're under a lot of stress right now, and our bodies are responding to that stress in certain ways. So maybe we become more tired when we get more work placed on us. So you're going to look and see what direction does the reaction shift. So let's do, I'm going to leave number one up to you. So you're going to have to figure this one else on your own. And when you submit this document, I'll share the answers with you. Okay, so for this second problem here, notice that they have 1 plus 2 moles for the reactants, and for the product, they have 1 plus 4 moles. Okay, now with gases, if you are changing pressure, you're going to shift it in the direction If it's high pressure, it's going to go to the lower moles. If it's low pressure, it's going to go to the side with the higher moles. Now here, they're asking us, it's an endothermic reaction, okay? And because it's endothermic, that means actually that the heat is on the reactant side. So when you're talking about endothermic, heat is on the reactant side. So if we want to increase more product, there's a couple things that we can do. So the first scenario, they say decrease the concentration of the dihydrogen monosulfide. So that would be this here, okay? So if they decrease the concentration, that is going to cause the shift to go towards the left, because it's almost like removing reactant, so we probably don't want that. Now they say increase the pressure of the system. Okay, if they increase the pressure of the system, the smaller number of moles is on the reactant side, so that will actually shift to the left. Now they say increase the temperature of the system. Okay, with endothermic reactions, because the heat is on the reactant side, if you increase the temperature of the system, the reaction is actually going to produce more product because it wants to use up that extra heat. So you could almost say that that heat that's on the reactant side is sort of like a reactant. It's trying to be used up, so it's going to produce more product. And we want to go to the right, so letter C is correct. Now they say increase the concentration of carbon disulphide. That is just like adding more product. And when you add more product, that's going to shift it to the left, which is what we don't want. So D would not be correct. And then lastly, they say decrease the concentration of methane. So decreasing the concentration of methane is just like removing a reactant, and it's going to shift to the left. So for number 2, the only correct answer would be C. Okay, I'm going to do one more of these, and then I'm going to set you loose for the remaining ones. Okay, so they say for number 3, what happens to the position of equilibrium when the following changes are made to the reaction below? Okay, so sulfur dioxide is product, and if they are adding product to the system, it's going to shift towards the reactants because you want to use up the excess sulfur dioxide, and as a result of it, you're going to get a shift towards reactants. Now, sulfur trioxide is removed from the system, so since it is being removed from the system, more reactants have to be made. So the shift is going to be to the left again. Oops, sorry. And then lastly, oxygen is added to the system. So whenever you add products to a system, it's going to shift in the opposite direction. So as a result, more reactants are going to be made, and the shift is going to be to the left. Okay, so go ahead and try the remaining parts of this worksheet, and when you submit your answers, I will share the answer key with you.